civil protection, your police, and the general public. Situations like we've had in Italy. So you don't want the two mixing. They want to be routed totally separately, but they need to be prioritized. The key people cannot be startup resource. This technology is already there. And radio sharing, radio network sharing. Once again, a very interesting concept to be able to grow the network as we believe, and what we're seeing are LTE islands. So you do need, to be able to get a wider area coverage, you do need some type of an MVNO. And clearly deploying LTE alongside technologies. This is not a replacement, and no technology makes any sense if its first deployment does everything. No technology is perfect from day one, but it does answer some key requirements that we found from our customers. Definitely video and low latency are the two main things that I can say have changed the way that we've seen people operating. Once again, another thing, I believe in AR APIs on whatever will be this type of network, because every vertical will have their own slight different things that they want to do. You need to have some APIs to be able to allow that vertical to build its own specific application interfaces, query the network, and get information. An open API for that using standard, cheap, off-the-shelf technology is key here, once again, to keep costs low. So, a distributed network of coverage islands is the cost-effective way that we believe things can be done using LTE for mission-critical applications. So, this is an example of what we have deployed. This is exactly the system that we've deployed on the earthquake, which is running right now on top of the school in the Emilia region. It's just a basic base station, full core network, and it gives users 100 megabits per second, over 100 megabits per second capacity, 40 megabits uplink. I'll show you later a little bit more figures, but allows lots of video, fixed, and mobile cameras. So it uses low-cost terminals. That's the other key thing. This was the requirement that we were asked. They wanted to have terminals that, if they were lost, they were broken, it just didn't matter. And that people were used to using. Standard phones, dongles, and so on. Little LTE Wi-Fi routers. And that's what we used. Low latency, another important, really important key. If they need to do something, control a sensor and so on, it needs to be very low latency, it can be seconds. Transportable, in our case, this was really important. Size, weight, and power was critical. Not only has very little power, it needs to run on a generator. The size needs to be compact. The weight needs to be decent for someone, to carry it on top of a school building and set it up. Quick to deploy, not the standard telecom way. Much more an IT approach. That's what we've learned. The people on the ground need to, as in the earthquake, they need to leave 3 o'clock in the morning. They need to be in 3 hours there, have everything deployed, and they're not going to have any of us there. So it needs to be very simple, plug and play, switch on a web interface, configure what they need to as if it's a standard commodity, and start running. Give out dongles with SIMs, start putting out the video cameras, fix them, and so on. And clearly cost effective. We're going, the direction that we've been pushed in from our customers is more and more an IT application. It looks much more an IT application than telecoms, apart from the here are radio components that are there. This, by the way, is a Nokia Siemens Networks standard base station that operators are using. And simple to set up, as I've already said. Video was the critical gap. So simple and cost effective. These were the key things. We found that many things in common with operator networks. I mean, clearly you can reuse all your dimensioning, planning, and everything. The technology is the one that is there with prioritization. with security. The apps are similar. They're already using some of those apps themselves. There are, in our case, the civil protection was also having some other IP apps that they already have, which could automatically be used on this network as its IP. The network needs to provide a guaranteed service, so reliable. It doesn't matter what goes down, it needs to stay up. So, and the advantage here is if you're using operator developed technology, it is meant to do that. I mean, an operator can't lose a base station. They're going to lose lots of revenue if the base station goes down for an hour. So that helps. The flexibility, ability to integrate specific applications in as simple as enough way, sort of, once again, IP approach. SIM-based as a basic security, and then adding on IP security as needed, standard. And again, simplicity was the key thing they asked us. If this is complex, we're not going to use it. Just switch on, use it, it works. Otherwise, we're going to throw it away, we don't have time. We have very few people on the ground. So, simplicity is key, reuse commercial technology. This is an actual image from what we have still running today in the earthquake zone. We have a collaboration with the civil protection of the Friuli Venezia Giulia region. This is an interesting new device that we integrated, which is a Zcam camera, which we have on our booth. Some of you are interested. It gives real-time video streaming and audio, VoIP, on the ground so that you can see what the person is seeing and you can talk to them. Now, they're accustomed to using standard applications. This was a little bit of a change, but dongles, Wi-Fi routers, and so on were the other standard things they were using. Now, normal public networks go down. I think we've said it many times. They go down either because they're damaged, like in the earthquake, or because they're overloaded. Off-the-shelf devices were a must here. Prioritization, once again, simple. And now, one of the reasons why we deployed this device and why we think this is really key, and one of the killer applications we have on LTE is some of the people on the field have never been to the field of operations before. They didn't know where to go. They could not talk in some situations. You can't talk everywhere, but you can listen. They do not always have information that field command has, so they can't tell if it's a dangerous situation or if they're seeing something that they should be reporting. So, giving real-time video, and we're talking about quite good, even the nice thing about LTE is at the cell edge, you can still get a very good picture as a difference from UMTS. So you can easily stream 1.5 megabits per second on these cameras, which gives you a pretty good video image. And they often need to be on the move. They need to drop fixed cameras here and there. They need to do surveillance. Unfortunately, the bad side of people comes out in some of these cases, so you need to make sure no one is doing something funny. A lot of the areas of the city are closed off. You can't get in there, and they need to be controlled. So the interesting image here is these are, I think there are about 30 fixed cameras that have been distributed around the area. These are all connected by LTE, and this center here is a mobile command center in a tent that is actually using LTE to receive all the images from the cameras. Consider that each of these images is about a megabit per second. So we're talking about a good 30 megabits per second there in the downlink, and each 30 megabits clearly also in the uplink, which is something you could never be able to do in UMTS. This is clearly something innovative. Just to conclude, I mean, this is something that was developed together with the civil protection, which I think has a great hand in here. We're also proud to say that we were awarded a medal by the President of the Republic of Italy for this work, for being there on the ground quickly and for enabling not only the professional workers but also civilians, because clearly there were difficult situations, people couldn't get back to their homes, at least giving them some way to communicate when mobile networks were having problems was really important, by giving them little Wi-Fi islands. So we were putting LTE routers, which some of you can see on our stand, LTE routers with Wi-Fi there, and they could connect and communicate. And that's starting to be a key thing. I mean, connectivity is really becoming important. You can't do without it. That's really it. What I'd like to show you just as a closing thing is the actual